Okay, I'm going to review with you your homework assignment or your classwork assignment over 7-3, special right triangles. First thing I want to do for question 1 is identify this angle measure down here, and it would be 60 degrees. So we recognize that we have a 30, 60, 90 right triangle, and we remember that for a 30, 60, 90 right triangle, the hypotenuse is always twice the length of the shortest side. And then the middle side, or the side opposite the 60-degree angle, will be the shortest measure times the square root of 3. So working this particular problem, we have opposite the 30-degree angle, we have a measure of 5. And so first thing we're wanting to do is find the value of x, which is the length of our hypotenuse. Since the hypotenuse is opposite the right angle, we'll look up here at our formula, and we find that it is 2 times the value of x. And 2 times 5 will be 10. So the value of x is 10. Then to find the value of y, we recognize that it is opposite the 60-degree angle, and the side opposite the 60-degree angle is always the value of the shortest side of the triangle, or the shortest leg, times the square root of 3. In this case, that would be 5 radical 3. So the answer to number 1, x is equal to 10, and y is equal to 5 square roots of 3. For question number 2, we have a 45, 45, 90 triangle. And so I'll write down the formula for that one. A 45, 45, 90. The two legs on the isosceles right triangle are the same. The hypotenuse is always that value, or the value of the leg, times the square root of 2. So in this case, we're given one of our legs. We know that this leg and this leg are congruent, and so the value of x would have to be 8 because those sides are marked as congruent. The hypotenuse will be that value times the square root of 2. In this case, 8 times the square root of 2. All right, in problem number 3, we have a 30, 60, 90. I'll go ahead and mark that angle. And again, I'll write down the formula. For a 30, 60, 90, it's always x square roots of 3, and 2x, where the hypotenuse is always twice the length of the shorter leg. In this case, we're given the hypotenuse, so 2x in this case is equal to 14, and we divide by 2, and 14 divided by 2 is 7. So the side opposite the 30-degree angle, which is what our x is referring to here, will be 7. And opposite our 60-degree angle will be that value, 7, times the square root of 3. For number 4, we have a 45, 45, 90, so I'll write that down one more time. X and x square roots of 2. In this case, we're given the leg again, so our x value will be the same measure because it is again a leg, and then our hypotenuse will be that value, that leg value, times the square root of 2. Okay, so good rule of thumb, if we have a 45, 45, 90, we're always remembering we're going to have a square root of 2 involved. And if we have a 30, 60, 90, we're always going to have a square root of 3 involved in our problem. Number 5, we have a 30, 60, 90. So we'll look at that one again. Rather than writing the formula down, I'll recognize that up here in our formula that we have this time the measure of the angle, or excuse me, the side opposite the 60-degree angle. And so it's going to have a square root of 3 with it typically, and it does. So the value in front of that square root of 3 is the value or the length of our shorter leg. So in this case it would be 9. And to find our hypotenuse, we just double that value, multiply by 2. So 9 and 18 are the x and y values for number 5. For number 6, we have a 45, 45, 90 again. And we see that the two legs, or we know that the two legs are congruent, and that the hypotenuse is 13 square roots of 2. So in the formula for a 45, 45, 90, it's always x, and x square roots of 2. So in this case, we have the x square roots of 2 part, which is opposite the opposite the right angle on the hypotenuse. So we just have to look at the number in front of the square root of 2, and we get 13. So both x and y are 13. flipping over and looking at the back side of that, I copied it on a separate page so it wouldn't bleed through. Number 7, we have a 30, 60, 90. So I'll identify that this is a 30-degree angle. Our hypotenuse is 15. So in a 30, 60, 90, remember that it's always x square roots of 3, and 2x. So in this case, opposite our right angle, the hypotenuse is 90, it's 2x. So we'll set 2x equal to 15, and we'll solve for x, and we'll get 15 over 2. So x in this case is 15 over 2, or if you prefer decimals, 7.5. And then our y value opposite our 60-degree angle, we always take the shorter leg and multiply by the square root of 3. So 15 square roots of 3 over 2. 15 square roots of 3 over 2 will be the length of the side opposite the 60-degree angle. Okay? In number 8, we have two sides that are marked to be the same. That means they're congruent. So that means we have a 45, 45, 90 triangle here. Since one of our legs is 34, our other leg must be 34 because all isosceles triangles have two congruent sides. Then our hypotenuse is that value times the square root of 2. So 34 square roots of 2. For number 9, we don't have any angle markings, but we do know that this side is half of the hypotenuse. Well, when we have half of the hypotenuse, we have a 30, 60, 90 triangle going on here, more than likely. And in this case, that's what we wanted to recognize here. So we have a hypotenuse of 20, a shorter leg of 10. So this angle would have to be the 30-degree angle. So x is equal to 30 degrees. And then y would be the length of the side here. So the side opposite the 60-degree angle is always the shorter side times the square root of 3. So 10 square roots of 3 in this case. For number 10, we have two sides that are congruent. Our y value would be 45 then because it is the measure of a angle. So it would be 45 degrees. So I'll mark that as 45 degrees. And then to find the length of x, or the value of x, the length of that side, we recognize that the hypotenuse is 2 square roots of 2, and the hypotenuse in a 45, 45, 90 triangle is always a number times the square root of 2. So in this case, we have 2 square roots of 2, so the length of our leg would be 2. And number 11, we have a 30, 60, 90 triangle. We recognize that opposite the 60-degree angle is the measure 15, and in a 30, 60, 90, we know that the hypotenuse is always 2 times the length of the shorter leg, and that the side in the middle is always that shorter leg measure times the square root of 3. So in this case, we have that measure to be 15, and it has to equal x square roots of 3. And as we've discussed in class, if we have a situation like that, in order to get x by itself, we have to divide by the square root of 3. But from Algebra 2 class, we can't just divide by the square root of 3. We have to rationalize that denominator. And in order to rationalize the denominator, in this case, I'll multiply by the square root of 3 over the square root of 3, which would then give me 15 square roots of 3 over 3. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 simplifies to just be 3. Then I will divide out here. 15 divided by 3 is 5. So x is equal to 5 square roots of 3. Then the hypotenuse was always twice as big as that, so 10 square roots of 3. For number 12, we have a 45, 45, 90, and we'll recall that in a 45, 45, 90, the hypotenuse is always twice as long as either of the two legs. In this case, the hypotenuse is twice as long as the leg. So in this case, I miswrote that. That should be x square roots of 2. My bad. Not twice as long. It's twice as long in a 30, 60, 90. So we take x square roots of 2 and set it equal to 28. In order to get x by itself, we need to divide by the square root of 2. Very similar to what we did before, we have to multiply by the square root of 2 over the square root of 2 to rationalize our denominator. We'll get 28 square roots of 2 over 2. And then that reduces to 14 square roots of 2. So x and y are both the same, 14 square roots of 2. And you can use Pythagorean theorem to check that out and see that it truly does work out to be 14 square roots of 2. Okay. For number 13, that's a 60-degree angle. So we have 18 opposite our x square roots of 3 side. And in class we discussed about the quick way of doing that. Divide the number by 3 and add a square root of 3 onto it. So 6 square roots of 3, and the hypotenuse is always twice that. For number 14, same situation with a 45, 45, 90. We always said you take the hypotenuse and divide by 2 and tag on a square root of 2. And so x and y in both cases will be 25 radical 2. For number 15, we have a 30, 60, 90 and a 45, 45, 90 triangle that are combined, joined together there. They share side W. So in order to find the W value, we recognize that it's opposite a 30-degree angle, and the side opposite the 30-degree angle is always half the hypotenuse. So in this case, we'll take half of 40, and we'll get that that is 20. So W is 20. Then to find x, we take that value and multiply it by the square root of 3, because that would be the side opposite a 60-degree angle. To find the value of y, we recognize that we have a 45, 45, 90 triangle going on here, and that w and y have to be the same. So that would have to be 20. And then the hypotenuse is always the square root of 2 times the length of that side. Okay, that's a review of your classwork. Be sure you have your homework done and ready to turn in.